leads to mind. And 1 dozen means a dozen. There are 12 pencils. So, dozen means 12. Similarly, I say, we have 2 dozen eggs. 2 dozen x, so when 2 dozen, then you have dozen means 12, 2 dozen 12 asterisk 2, it means 24x. So, whenever we talk about dozen, then dozen means 12. Similarly, when you read calculations, you read one word, deca, hecto, kilo. Deca 10, I means decameter. 1 decameter means 1 decameter is 10 meters. I means 1 hectometer, hecto 100, it means 100 meters. 1 kilometer, it means 1,000 meters. So, deca 10, hecto 100, represent kilos, dozen 12, deca 10, hecto 100, represent kilos. Now this is a simple thing. Now let's say I have 1 mole of eggs. It means I have a total number of eggs. Just like a dozen represents 12. In this way, the number used to represent moles is 6.02210 to the power 23. This number is called a total number. So 1 mole of X means a total number of X. I say there are 2 moles of sand particles in the desert. It means 2 asterisk a total number of sand particles in the desert. But here students have a problem. The problem is this. The problem is that above we said 1 dozen eggs or 2 dozen eggs, so the eggs can be small or big. I said we have 1 dozen bananas equals 12 bananas. Now those 12 bananas can be more or less in size. But when we say 1 mole of particles, that is called a total number of particles. The particles here should be identical. Remember one more thing. I want to bring this to your mind again and again. Remember it again. Students, I taught you 4 types of substances in the last lecture: element, molecular compound, ionic compound, and ionic species. You'll need to memorize the smallest particle of these substances. So, remember 4 things. The smallest particle of an element is an atom. Secondly, the smallest particle of a molecular substance is a molecule. Third, the smallest particle of an ionic compound is a formula unit, and the smallest particle of an ionic species is an ion. So, an atom is the smallest particle of an element. An atom is the smallest particle of an element. An atom is the smallest particle of an element. A molecule, a molecular compound formula unit, is the smallest particle of an ionic compound, and an ion is the smallest particle of an ionic species. This needs to be kept in mind. If we don't understand this, we can't proceed further. Now, what is the relationship between the number of moles and the mole? Let's discuss it a little more deeply. Student, I have an electric balance. This one is a highly, very sensitive balance. Just imagine, suppose this balance, an electric balance, can measure the mass of individual atoms. Although we've already studied that it's very difficult to measure the mass of a single atom. But let's imagine you place carbon atoms on this electric balance. Where would you get carbon atoms from? Take them from diamond, take them from graphite. Keep placing carbon atoms on top of it one by one. You keep placing them. Keep placing them. I'm assuming you placed a number of carbon atoms on this electric balance. Now I want to know how much these carbon atoms weigh. What is their mass? So I looked at the reading and found it was 12 grams. It means the mass of these carbon atoms is 12 grams. And I call this one mole. Similarly, instead of carbon, you go to magnesium. Magnesium is also an element. Keep placing one atom of magnesium, another, and a third. You placed a number of magnesium atoms on this electric balance. Take their mass. When you calculate their mass, that is 24 grams. It means the number of magnesium atoms has a mass of 24 grams. And that is called 1 more. Well, you should note one thing. You use the same number of atoms for both carbon and magnesium. The Avogadro number, but the mass of the same number of carbon atoms is twice less than the mass of the same number of magnesium atoms. It is half. The mass of carbon's odd number of atoms is 12 grams. The mass of magnesium's odd number of atoms is 24 grams. This means that one atom of magnesium is twice heavier than one atom of carbon. It is twice as heavy. It is exactly like when I tell you that you have 12 apples and you have 12 watermelons. Now the number of both is equal. 12 apples, 12 apples, 12 watermelons, 12 watermelons. The number in both is equal. 121, but is the mass of 12 apples equal to the mass of 12 watermelons? The answer is no. The mass of 12 watermelons is much more than 12, that is, 12 apples. We did the same thing there too. We said that magnesium has 12 atoms, its mass is more than the 12 atoms of carbon. Notice one more thing. I discussed this at the elemental level, so let's move on to the molecular compound of carbon and magnesium. I have water. The same electric balance contains water molecules one by one. It's a molecular compound. The smallest particle is the molecule. You just place one water molecule after another. You place the Avogadro number of water molecules on this electric scale and on the balance. Now you want to know their weight. So when you find out the mass of the Avogadro number of water molecules, that's 18 grams. So I'll say the Avogadro number of water molecules is equal to 18 grams, and that's 1 more. Now notice one more thing. If you multiply half of the Avogadro number, 3.0110 to the power 23, by half of the Avogadro number and place the water molecules, and then calculate their mass, then their mass will definitely be 9 grams. 18 grams is 1 mole of a molecule, and if we take 9 grams equals 5 moles, that is half the number of a mole of a mole. These are basic things, so what did you